Let's talk about single variable. So for example, there is a function is given like this, x squared minus 1 over x minus 1. Right? Let's assume x equals to 1 and substitute into this in this function and find out the value of this function. So take a look. 1 squared minus 1 over 1 minus 1. So it's going to be 0 over 0, which is indeterminate form. You can also call it trivial value. And usually you use do not exist. Or basically you're saying, I don't know what's happened to the function at this point. It's infinite. I don't know, it's too small, too big. You can really doesn't tell about anything about this function. Okay. Now instead of x equals to 1, let's see what happened when x approaching to 1. Approaching to 1 means x is going very close to 1, but not at 1. Not at 1. Okay. That's why I'm using the arrow. I'm not using, there is a two different thing. You can make sure that when I say x, arrow is means approaching. X equals to 1, x approaching to 1 is two different things. It means x equals to 1. Here means x is not equal to 1. It's going to be towards 1. Okay, closer to 1. So that is good thing. But before we do this thing, there is another way you can look into that. So there is a 1. X can approach this 1 from this side, and x can approach this 1 from negative side. Right? It's going to be negative side and going to be positive side. That's way. So maybe you can go into 0.9, then 0.95, then 0.99. Here you can say is 1.1, then 1.05, then 1.001. These are the two ways you're going towards 1. So let's do both. X approaching to 1. Here is maybe positive side. Here is negative side should be. And here is from positive, right? It's going to be 1 is here. They are approaching this side and they're approaching this side. Okay, that is my pretty much goal to focus on right now. So positive side, let's do this one negative side. So you're going to put x equals to 0.5, x equals to 0.9, x equals to 0.99, x equals to 0.999, x equals to 0.9. Okay. You can split further if you want, but I think it's a good starting point. And here I'm going to be writing my function is, this is my x value. These are, and if my function is this x squared minus 1 divided by x minus 1. So if you substitute this value from your calculator, the answer will be 1.55000. You substitute 0.5 here in x squared, is going to be look like this. If you substitute 0.9, it's going to be 1.90000. You further exploring much more with going 2 decimal places, it's going to be giving you 1.99000. Am I determinant? I mean, going to the indeterminate form. No, indeterminate form is not approaching, so I'll keep going on. One more time, if I do 999, 3 decimal places is going to be 1.99900. And if I substitute in this fifth one, which is have 5 decimal places, it's going to be 1.99999. I'm pretty close to go one more adding one more iteration. It should be start giving me 0. Infinity. If I substitute x equals to 1, I know that it's not possible. So what I'm going to do, I'm going to stop here and then exclude this iteration. If I'm going to go to the other side, which is a positive end of this, so I'm going to do the same thing, x and x squared minus 1. Here I'm going to be starting from the positive side. It means I'm going to be going from x equals to maybe 1.5, then 1.1, then 1.01, then x equals to 1.001, then x equals to 1.0001, and my final pretty much 1.0000 and 1. So 5 decimal places. If I substitute 1, the first one is going to be 1.5 squared minus 1 or 1.5 minus 1. So the denominator on the numerator, whatever is coming, the denominator is going to be 1, right? Really, so it's nothing left, 0.5. So nothing left much over here. You can solve it. You're going to get some value. Since we have a limited time, we're going to waste time on other things rather than here. So we substitute this. We got 5 decimal places. 1, 2, 3, 1, 2, 3, 4, 5. Yeah, 5 decimal places. And I substitute x equals to 1.1. It's going to be 2.10000. And I substitute x equals to 1.01. It's going to be 2.0100. Same thing if I substitute further. And the last one is I know if I substitute further, if I go another iteration, I say that x equals to 1.0000 and then 0. I know my function values becomes infinity. So what I'm going to do, same thing. I'm not going to be including this guy. Right? So if I look into that, this value and this value, that pretty close is about 2. So I can write like this, limit x approaching to 1, x approaching to 1, not approached yet, not there yet, x approaching to 1 for this function. My limit should be equals to 2. Right? My limit is equal to 2. It means I make an assumption. Based on my math, I make an assumption. I'm saying, for some reason, x is coming, let's suppose this is, 1, 2, my function is coming here, and getting a spike and come back. So I know my function actually approaching to 2 when my limit of x equals to 1, but they got some spike. So what I'm going to do, I'm going to just chop this spike artificially. I'm going to cut from here, I'm going to cut from here. I'm going to take this spike, right? And then throw away. And then say, you know what, my function is coming here, and that's like that. Okay. So that is the 1D. So if I'm going to be moving forward to the continuity part, let's talk about the continuity. What is a continuity? And then we're going to come back to this limit for two-dimensional theorem, two-dimensional variable. And that is what our goal is today, to work on this two-variable function. This one is easy, probably you learn. One thing you notice, you guys been told many times probably, using your answer for 3 decimal places, 4 decimal places. Every time you do your calculus 1 probably or pre-calculus class, your instructor definitely, I don't know whoever is that, but whoever is your instructor, more likely they're going to push you too much about how many decimal places. You should not basically round up anything, should not round up anything. And the reason they're asking you to not round up anything, because if you think about it, if you start rounding of this or rounding of this, all this math have no meanings. You can just write this guy to 2 and write this guy to 2 and write this guy to 2 and write this guy to 2 maybe. Depends on how aggressive you're rounding off your digits. Same thing here. These all values, if you're rounding off, you can say is 2, but they are not. You can see here. It's a big, it would be a big challenge if you stop your limit calculation here or here or here. Depends on how accuracy do you need in your system. So probably today you know why the calculator limits, if especially for limit problem, why these decimal places is very critical. Let's talk about continuity. So continuity means, look, if you have any holes, right, or jump, or maybe asymptote. In the system, or function is called not continuous. Right? You can call it not continuous or discontinuous. Okay. For example, I have 3 examples. What kind of those holes means? Your function is coming. It's very small, so you have to put a little hole here. If you look into that, it's going to be look like the function is coming from one side and then going on the other side. It does not have this. So this is my hole. Okay. The other one is called jump. A jump means function is coming from one side and then going to another side. It does look like it's okay, but if you put the microscope on, here, and gonna make it a little bit bigger so you can see much clear what's going on here. The function is coming here and then going from here, and that is a jump. That is a jump. The third type is asymptote. Asymptote means the function is coming for y asymptote is gonna coming, and as soon as you come approaching to the y, just keep going up and up. Right? It's not really touching. You don't know what's happened to this function. Same thing, the function is coming here, is going to be, if you just dotted this line, right? So this is called not continuous, or maybe you can say, right, my function is okay. My function is okay up to this point, but something happened afterward is incontinuous. So I just ignore this part. I'm fine with this part. Left side is fine with this line. Right side does not. Okay. And this is a whole scenario. You can say vertical asymptote. Same thing, you have a horizontal asymptote, you can just draw according to x-axis. Okay. So that's one part. Let's move on to another little thing before moving forward. Recently, we talk about domain, right? So one thing is that domain is so really what's happening to the function. I talk about these domain values to you. Domain means I give you the value of x where the function is defined, right? And after this function is infinite, maybe after the function infinite. So you just keep it here. This is my domain. If you take the value of x in the domain, whatever value is given, you put in, they give you the function value here, right? And this function value, what you got in the y-axis, you call it range. So this guy is range. Okay. Now let's talk about function of several variable or more than one variable. This is basically just a little topic like range and domain. So you know what is range, what is domain. Not a big deal. We already talked about these things in our previous lectures. So limit in 2D space, limit in 3D space. Okay. We recently did a very simple example that elaborated pretty nicely. If I have a function like this and I want to know, hey, what is the limit at this point? Let's suppose something happened at this point. I don't know what is that. Maybe spike, maybe break, maybe jump. And I want to know. So what I'm going to do, I'm going to just substitute the value x naught, and I find the value of y naught and give it, putting it into this equation, and then I give you the value for the function. And I also learned that I should be coming this side, and I also coming that side in the function. So I can say it's coming from positive, and I'm coming from, sorry, this should be positive, and coming from x from negative side of this one, of this point. So I'm not saying the x-axis is positive or negative. The left side of this function considered negative. The right side of this function considered positive. And what we learn, if in order to get the limit, my x approaching x naught, which is this guy, from positive side of the function must be equal to limit approaching this function from negative side. They must be equal to the negative sign. So the function should have a negative values on this point. So if these are to equal, I say limit exist. Okay. But if they are not equal to each other, I can say limit to not exist. Or usually we can call do not exist, DNE. That's 2D. For 3D space, let me talk about 3D space. It's going to be like this, this, draw different ways, this, that. And if I draw a function here for my space, 3D space is going to look like, and my point is somewhere here. And I'm asking you, hey, this point is continuous or not? Tell me this point is continuous or not. This is my, focus point. So in this case, what you can do, you can draw a perpendicular. Right? And then here, you can connect this point to here and there. And then finding the value of y naught, maybe, no, sorry, this one will be x naught, and then it's going to be y naught. Okay. Then you say here, you're going to say limit xy, since you have two functions, two variables, let's say xy, and putting x approaching to x naught, y naught. What is the function values? Now here's a little caveat, right? We can approach to this scenario from many different ways, right? We can approach to this location in many different ways. How? Let's take a look. So if you're approaching this point, let me just draw here something. Let's suppose this is a point. You can approach from here. You can approach from here. You can approach from here, here, here. So really, you have so we have infinite ways to approaching this point, which is my x naught, y naught, right? And if it's x naught, y naught, if it's a three-dimensional, there are infinite ways to approaching x naught, y naught, z naught. And that's where a little bit tricky things start. So we probably creating a function, we're creating a ways to how to solve this issue in a little bit better way. So we do not have to be stuck into this kind of situation. And we're going to check. So we have many ways, but we're going to check at least two ways. We have infinite ways, but what we're going to say is check at least two ways. Two ways means from two sides. So one is this, maybe I can say this side, and one is this side, like this way, coming from x, y. This line is dotted line. I'm going to come from this way. So two ways, actually check at least two ways, which ways I can say is along x-axis and along y-axis. Okay, so let's check some problems, and then that's what we're going to jumping into that. So let's take a look another problem. If the example is giving you like this, maybe function is giving x y equals to minus xy over x squared plus y squared. Need to find limit and approaching to 0, 0, and for the function. When function approaching to 0, 0, find the limit. Okay. So point is that I'm going to be supply. So I just apply without thinking about it. I'm going to just apply this whatever we know. A part, we're going to apply limit, right, along x-axis. When I say along x-axis, it means I'm going along x-axis like this way. So along x-axis, y value 0, right? Along x-axis, y value 0. So I'm going to substitute this. So I'm going to write limit x approaching 0, x and y approaching x naught, y naught, and then my function is giving this. And if I substitute the limit, I'm going to say is limit y is already gone. There's no more y here. So I'm going to say only x left over. X is approaching to 0, right? And if I want to eliminate this thing, I can eliminate, because right now x naught and y naught in my case is 0, 0, which is we already talked about. This is x naught, right? These are the points you are approaching. So the bottom line is that I completely remove this y part because y equals to 0 since we are talking about x-axis. So what is left over if I remove the y from this function, or by substituting 0, left over function is 0 over x squared, right? Like this is my function. And if I substitute y equals to 0, y equals to 0, it becomes 0 over x squared. And that is what I wrote here. Okay. And if I'm going to continue this one calculation here, if I substitute the value of is going to be 0 or 0, the answer would be 0. Let's do the B part. Limit along y-axis. When I do the y-axis, my x value should be equals to 0. And we do the same thing, which is right here. That is my little limit. And here I'm going to be substituting limit y equals to or approaching to 0, but my x is supposed to be gone. And how is going to be gone is going to be x, y, minus xy and divided by x squared plus y squared. I substitute x equals to 0, so it's going to be 0 with minus sign, then y squared and 0 squared plus y squared. So really this guy is gone. The only thing left over is 0 on the numerator and denominator is only y squared. So I'm going to write here, like what I just did on the right side, 0 over y squared. If I substitute this 0 on the y squared, the answer will be 0, right? So look like both sides are equal. So I'm going to say my limit is approaching and I'm good to go. My limit does exist. That is my takeaway from this. Okay. Let's take a look at another problem. Sometimes limit is not have some particular number like 1, 2. Function is this and this one. Okay. I'm going to try to use this directly, and if I give me the answer, I probably, so I'm applying directly this limit and see if I get the answer. And if I get the answer, I don't have to do all kind of work. So let's substitute 5 x squared y for x squared plus y squared. I distribute this and I substitute the limit 1 and 3, 1 and 2. Right? If I substitute the limit here, is going to be 5, 1, 2, and 1 squared plus 2 squared. So if I say it's going to be 10 over 5, yes, and the answer is 2. I get the definite answer. I get the answer, so I'm good. Yeah, limit does exist. Since it's a 2 variable, but I substitute, I get the. Let me just do another problem, vice versa, into this, so you get a good understanding of what's going on here. So limit and the question is this: x squared minus y squared divided by x squared plus y squared. And I have my whole function is in the parentheses and they are with the square. Okay, let's apply the same approach here, right? Same approach. I'm going to substitute the value and see what's going to happen here. Solution here. Maybe I'm going to substitute the value directly. Since 0 squared plus 0 squared minus 0 squared divided by 0 squared plus 0 squared. Whole thing is 0 squared, and 0 over 0 is, I don't maybe it does not exist. I'm not, there's infinite ways I'm approaching this function. Remember, I'm going to draw here, if you guys remember this, I draw something like this. And I have to check at least two ways. So I'm going to be checking A, B, along x-axis, along y-axis. When I say along y-axis, y equals to 0, along y-axis, x equals to 0. So if I substitute the value here, I'm going to say is limit y approaching to 0, and I'm going to substitute, I think it's going to be, let's substitute some value, says x squared, or it should be x squared divided by x squared. And limit becomes this kind of the cancelling out has become 1, right? It becomes 1. It becomes 0. The cancelling out becomes 0. And here, if we see, let me see if I can get a different answer over here. Limit y equals approaching to 0, and here, and I similarly with the x, so it's going to be minus y squared over y squared. So we can do one thing. If I canceling out this, it's going to be a little bit different. By canceling out this, everything is gone. Inside this thing left over 1. And really, I does not have to apply any limit. So my answer will be 1. Because I no value of x left. Same thing here, if I do this guy, it's going to be left over inside is minus 1 squared, and it's going to be 1. So really, if you see both sides, I got same answer. And our goal was to check if we can see both answers existing, so it means limit exists. And what is the value of the limit? We really doesn't care what is the value of the limit, but if you got 1, then 1 is our limit. This question you really doesn't care much about the value, but the value should be same. Okay.
Let's take a look at another problem.
We are pretty much heading on time. Let's check this function. Okay, 0, 0 function is this. So I'm going to see it here. I know it's going to be 0, 0. And I'm asking myself, hey, something going on here? Am I right? I'm not 100% sure. I have to do the test. And test is go along x-axis and y-axis at least 2 and see if both give me the same value. So along x-axis, along y-axis. When I say x-axis, y equals to 0 along x-axis, and here x equals to 0. Yeah. And if I want to do something graphically, I'm going to see, I don't know where the point is, but 0, 0 usually here. 0, 0. And really I'm approaching here. And I'm approaching here. And I'm approaching here. I'm approaching here. There is other ways you can approach from here. But definitely I cannot do all of them. Sometimes you also try a line. Very famous thing is line like this line. And the red color line is x equals to y. This line equation is x equals to y. So you take this and substitute and see what's happening. So I'm not going to be doing this. It's just a you know, we're just approaching to these from x-axis and y-axis and do our test. You see if you got the same value. So here limit 0 over x squared, because y is gone, pretty much y is 0, so everything becomes 0. And this is the leftover after I eliminate y. And if I substitute the value, it becomes 0, right? Here, I'm going to get limit y reaching to 0, and it's going to be, here I'm going to be eliminating x, so it's going to be y over y squared, pretty much. Maybe I can further simplify it. It's going to be limit y reaching to 0, so 1 over y, right? If I substitute this one, it's going to be, that's going to be infinity, 1 over 0, so dne. So yeah, that's a problem. This dne is coming one side and other side is not. So I'm saying limit do not exist for dne. And this dne is go for the whole thing. Okay. Just for homework, maybe you guys try something. Homework question. You pause the video and try this problem where limit
Thank you for watching Knowledge Academy. Please subscribe my channel.